So next, I'm going to talk about how Layer 2 addresses barriers to enterprises building on the Ethereum mainnet. I am Tosh Dienes. Again, I work at the Ethereum Foundation on ecosystem support. And one of the things I do is kind of act as a liaison to the EEA, including chairing the EEA mainnet interest group. So how does Layer 2 address barriers to enterprises building on Ethereum mainnet? First, well, let's talk about public versus private chains. So many enterprise applications have been built in the last few years on private blockchains versus public blockchains. So Ethereum mainnet is a public permissionless blockchain. Many enterprise chains are private permission chains. And the reasons for choosing private permission chains are often good and valid reasons, such as privacy and scalability. But there are some benefits to building on the public mainnet instead of building on private chains. So some benefits of building on the mainnet are stronger security and immutability, because the mainnet is secured by tens of thousands of validators running all over the world. It's more secure and more resistant to being changed than a small private chain that's running on a handful of nodes in a couple of data centers. Another potential advantage is operating cost. So this is not quite as obvious, but building and operating and maintaining a private chain can be expensive. And a report by Ernst & Young showed that for some applications, it's cheaper to run your application on the mainnet than to build all of that infrastructure yourself. Another benefit of mainnet is that it can act as a common frame of reference to solve this problem of having multiple isolated silos or isolated blockchains. So one of the problems that enterprises are finding as they build consortium chains or join into blockchain trade, track and trace, or other partnerships with their partners that involve blockchains, is that they have to integrate with many different blockchains. They might have to integrate with a dozen different blockchains or more, which is kind of an IT nightmare. And none of these things talk to each other, and they're kind of like isolated silos on their own. So by building on one common frame of reference instead of having all these different silos, you can avoid this problem of having all these things that don't work together, kind of like building on the internet where everything can talk to each other versus building on a private network where they can't. And then lastly, interoperability with other applications on the mainnet. So if you build something on mainnet, it has the potential, not guaranteed, but it has the potential at least to interoperate with other applications that are also on the mainnet and benefit from the network effects of all the people that are on the mainnet. Similar to, again, the internet versus a private isolated network that can't talk to anything else. So the premise of this talk here is that the evolution of layer 2 scaling solutions should lead enterprise architects to think differently and reconsider the public versus private decision. So first, what are layer 2 scaling solutions? What's layer 2? Layer 2 is a set of protocols that runs on top of Ethereum, which is layer 1. And the protocols inherit security properties from layer 1, but provide greater transaction processing capacity or throughput than layer 1 can provide. So if there's a dispute on layer 2, layer 1 can arbitrate and enforce the correct outcome. So layer 2 is secured by layer 1, but it has greater throughput, so it enables your application to handle more transactions or users or actions or data than layer 1. And there can be many layer 2s. You can have multiple layer 2 instances side by side. So you can have a public shared layer 2 instance that's shared by many applications. You can have private layer 2 instances that are used by only one application or one company's applications, and different technologies. And these can all coexist side by side. So layer 2 is not one thing. It's many instances of many different technologies that run alongside each other on top of layer 1. So there are many categories or many types of layer 2 solutions. Many flavors to choose from. You've probably heard of some of them, rollups and state channels and plasma and so on. I'm not going to get into the details, but I will divide them for the purposes of the talk. I want to divide them into two major categories: on-chain data solutions and off-chain data solutions. So layer 2s that write all transaction data to layer 1 are called on-chain data solutions, on-chain data layer 2s. And these include optimistic rollups and ZK rollups and certain hybrid solutions. Then we have a different category of layer 2s called off-chain data layer 2s. that do not write all transaction data to layer one. And the transaction data has to be stored somewhere, but it's stored somewhere else. That might be within a layer two network, might be on the client side. Point is, it's not written to layer one. And so this includes things like state channels, plasma, validium, side chains, if you consider them a layer two, which is an interesting debate, and certain hybrid solutions. So on-chain and off-chain data. This is going to come up back again and again. So how does layer two address enterprise challenges and objections to building on public blockchains? So we've kind of listed out some of the challenges and objections and thought about how layer two addresses them. So first one, kind of the most obvious one, is the scaling problem. Layer two is designed to solve the scaling problem. So if you have an application that requires hundreds or thousands of transactions per second, public chains can't handle that. This is exactly what layer two is designed for. So depending on the specific layer two technology and how it's implemented, your scalability factor will vary. You might get tens of X to 1,000X or more throughput on layer two than you can get on layer one. So on the high end of scalability, you've got the off-chain data layer twos, like state channels, plasma, validium, side chains, and certain hybrid solutions. And on the lower scalability end, but still significant, you've got rollups. And a related problem that layer two is designed to solve is transaction costs. Because if you're competing for scarce resources on layer one, transaction costs go up. So if you've been paying attention lately, you're probably aware that Ethereum gas prices are going up. And if you need to conduct a lot of transactions, it's going to be pretty expensive. So layer two helps here because a transaction on layer two that is anchored to layer one is much less expensive in terms of layer one gas than a transaction directly on layer one. And again, the savings factor depends on the layer two technology. Solutions with off-chain data are the most economical and get you the most savings because they write the least amount of data to layer one and therefore can consume the least layer one gas. But you also have rollups and on-chain data solutions that offer substantial savings somewhere in between. So next challenge is the speed and latency problem. And the problem here is that if you're a user and you have to wait 10 or 15 seconds for your transaction to be confirmed, or if you have to wait minutes for it to be finalized, that could be a bad user experience. And some applications this matters, in some cases it doesn't, like backend automated systems don't necessarily care if they have to wait a few seconds, but users kind of don't like to wait. So layer two can help here. It doesn't really solve this completely, but layer two can help because layer two solutions can provide instant transaction confirmations. You submit your transaction to a layer two block producer, and they can give you a receipt saying that they got your transaction and they'll include it in the next block. And potentially they can even give you an economic guarantee such that if they fail to include your transaction in the next block, you can punish them. So faster transaction confirmations. Also, layer two block time can be much shorter than layer one block time. So instead of waiting 15 seconds for a block, you might only have to wait 1 or 2 seconds for the layer two block to be produced. But the caveat is that finality, if you want full finality on layer one, then you still have to wait on the layer one time scale, which is a few minutes. So it doesn't solve this completely, but it does help. Next, we have what we've called the noisy neighbor problem, which is that if you are running your mission critical application on layer one, and the application depends on predictable timing, if layer one gets congested because of an ICO or a CryptoKitties application or something like that gets popular, that can affect your business. You don't want that. So layer one helps here, or layer two helps here because the less data is written to layer one, the less vulnerable an application is to congestion on layer one. If you're writing every transaction to layer one and doing every transaction directly on layer one, then you can be pretty vulnerable if you're doing a lot of transactions. If you're doing a lot of transactions on layer two and you're just anchoring them to layer one, it may consume far, far less gas, which means you're less vulnerable because if there is congestion on layer one, you can always pay more. You can increase your gas price and pay more to get your transaction through on time. If you're only using a little bit of gas with a few transactions, that may not break the bank. But if you're doing a lot of transactions and everything's on layer one, that may be prohibitively expensive. So layer twos with off-chain data use the least layer one gas, therefore they are the least vulnerable to congestion on layer one. Rollups, which have on-chain data, are still less vulnerable than layer one. They give you some safety margin, but they're not quite as immune as off-chain data solutions. And then sidechains are actually quite immune to this problem because they're kind of their own layer one. They do not depend on the main chain directly, except when transferring assets or interacting with it. Another way layer two can help here is that if you are running an application on a shared layer two, so you're sharing it with other applications, the layer two operator, if they choose, may be able to provide a service level agreement or some other assurance that your applications won't be competing for resources with other applications and will get some guaranteed allotment of capacity or throughput of resources. I don't think anybody's done this yet, but it's certainly possible, and I would imagine it will happen in the next year or so. And then finally, if your company can run its own layer two instance by itself to run just its own application or just your company's applications. Next, we have the challenge of data privacy and security. So much company data is considered sensitive or confidential, and businesses understandably don't like putting even encrypted confidential data on a public chain where everybody in the world can see it and hack at it. So layer two can help here because off-chain data layer twos, certain off-chain data layer twos, such as Validium sidechains and a hybrid one called Arbitrum sidechains and state channels, these are able to keep all of your layer two data within the layer two instance and off of layer one. So the confidential data that's transacting within layer two never leaves layer two. It doesn't touch the main blockchain, and it can be secured. So if multiple companies are writing data to the same shared layer two, kind of like a consortium chain, companies sharing that layer two may be able to see each other's data depending on the technology. But if a company has its own layer two instance, then that data can be kept very private. So layer two can help here, but ultimately I would say that the design pattern of placing sensitive data on a blockchain should be questioned, as there are different designs that avoid using blockchains as databases and instead focusing on using their strengths while keeping sensitive data off-chain. And a related problem is data locality. So not just is your data secure, but where is your data stored? There are a few laws and governments, such as GDPR is a law in Europe that requires data to be stored in a specific location or within a specific country. And also that you be able to delete data on request. So if you put your customer data, even if it's encrypted on a public blockchain, it's going to be stored all over the world on thousands of computers. You don't know where it is, you can't control where it is, and you can't delete it. So obviously not good. But if you use an off-chain data layer two solution for that, the layer two operator can provide a layer two service that stores layer two data in a known location. For example, you could have a layer two that's only in Portugal, all the servers are in Portugal, the data never leaves Portugal. So compliant with whatever laws Portugal may have about that. And a company can run its own private layer two. So a company can run its own, have its own layer two instance that has complete control over the location and security of the data that's stored on it. But again, ultimately, as before with privacy, the idea of placing large amounts of sensitive data on a blockchain is questionable. There may be different design patterns that avoid using blockchains as databases, but use them for their strengths and keep the data somewhere else. Next, we have what I call the responsible party problem, which is that companies are used to doing business with other companies, and if something goes wrong, they can hold them accountable. But if you're building something on a public blockchain and you need support or there's a glitch, who do you call? Who do you yell at? So this makes some companies uncomfortable. Layer two can help here because layer two instances may be run by an operator, which may operate that as a IT service and may provide SLAs and accountability and security in the traditional fashion. So the layer two operator may be the accountable party that you're doing business with rather than working directly on layer one. Another challenge that's been raised, I've heard this a few times, is that For some companies, especially kind of old-fashioned large companies, the idea of buying crypto and holding crypto and using crypto to pay for transactions is a little bit out there for them. They may be uncomfortable with it at this stage in the game. And getting their treasury to buy into that and to account for the crypto may be challenging. So layer 2 can help here, because if you are running on a layer 2 that's operated by a third party, you have to pay for the transactions, but you can pay for the transactions in fiat or coconuts or whatever the operator is willing to accept. It doesn't have to be crypto. So that the layer 2 operator can accept any form of payment, and you won't have to use crypto to pay them. This has also been addressed on layer 1 by a service called transaction relayers, which will accept your layer 1 transaction, relay it to the layer 1 network, and then charge you for that in fiat. So this problem has been addressed both on layer 1 and on layer 2. Another challenge or concern of certain enterprises is strategy leaks. If you are doing all of your transactions in public and your competitors can see them, even if the data is encrypted, they may be able to discern patterns from the metadata, especially if they can gather a lot of data over time and see what are your trends, who are you doing business with, is it going up or down? They might learn things about you that you don't want them to know. So layer 2 can help here, because again, off-chain data, layer 2s can keep that sensitive data off of layer 1. And if your competitor doesn't have access to that layer 2, if it's restricted, then they can't see it. Also, there is an emerging technology called ZK rollups. And this is a layer 2 technology that allows confidential transactions within the layer 2. So even if you and your competitors are all on the same layer 2, they won't be able to learn anything from your transactions. They can't tell who you're interacting with or what you're doing. And then finally, we have design patterns that have emerged in the last year or two. For example, baseline is a design pattern that involves transactions directly between entities, and the transactions are conducted privately, not on the blockchain, but they're enforced by a blockchain with zero-knowledge proofs of correctness that are submitted either to layer 1 or to layer 2. So in patterns like baseline, the blockchain is used not for the confidential transactions, but to enforce the correctness of the confidential transactions and to provide a sort of common frame of reference. And then finally, we have what some people have called the emotional challenge, which is that public blockchains like Bitcoin and Ethereum are still outside of some companies' comfort zones. So layer 2 is not a therapist, but it can help, because running your application on a layer 2 can provide a degree of isolation from the public layer 1 blockchain. You're not interacting directly with the layer 1, you're interacting with the layer 2, and the layer 2 can be operated like a traditional business IT infrastructure with security and accountability. And so it's kind of a buffer between your business and the unregulated activity or whatever's happening on layer 1. Excuse me, but you still get the benefits of having layer 1 under there as an umpire and giving you the security and immutability and the common frame of reference that layer 1 can provide. So in conclusion, with layer 2, you can get many of the benefits of building on the public Ethereum mainnet without some of the limitations or challenges that people have faced in the past. And layer 2 therefore can make it easier to build many types of enterprise applications on Ethereum mainnet. And there are other challenges and reasons why layer 2 helps that I didn't have time to get into, but there's an article I wrote. It's on the EEA website. So feel free to email me, tosh@ethereum.org, if you have questions, and I will post the link to this in the chat so that if anyone would like to read it later, they can do so.